Okay, so I think we shall start now. Yes, it is already 6:05, so we'll start. Let me share my screen. Uh, Please confirm whether it's visible or not, audible or not, my voice. So, hello everyone, welcome to the live interaction session on week 11 assignment session of Computer Integrated Manufacturing course, which is being instructed by Professor J. Ramkumar and Professor Amandeep Singh from IIT Kanpur. And this is Chinmoyi, the Emirate Scholar from IIT Madras. So this week, like in 11th week of lecture notes, we have seen the lecture sessions on material handling. So we'll see the questions which are being solved in previous year as well as this year also. We'll try to discuss the questions, few of the questions with explanation. So basically, if we talk about material handling, so it is that field where we can say the problems or the queries related to the like which involves movement, storage, like in manufacturing plant or warehouse, then control of that like and protection of materials, we can say goods and products. So throughout a process of we can say cleaning, preparation, manufacturing, distribution, then consumption, and we can say sort of disposal of all related materials like goods and their packaging. So are being like solved, we can say those problems related to that. So material handling industry like manufactures this and uh, distributes equipments and services which are we can say being required to implement material handling systems so that it can opting locally processing or shipping raw materials to we can say utilization of industrial feedstocks in industrial manufacturing system. So even if we see to the material handling processes, like we can see it ranges from simple pallet track to shelving projects to complex conveyor belt or automated storage and retrieval systems, or we have seen AGVs, automated guided vehicles. So from like it varies from the requirement and from work to work functions. So even it can consist of sorting and picking. So as like automated guided vehicles does. So it's like where like cost in material handling also is being like mentioned or is being even discussed that and like manual handling compared to the manual handling systems which were used to be in there in previous times. So the main objective of material handling system we can say like first handling, if we talk about that, primary handling objective in like warehouse or plant is to like sort inbound shipment according to precise customer requirements. So receiving uh, those three handling activities are receiving, in storage handling and shipping. So in receiving part, like we can say, when material reaches warehouse, so it has to receive, it has to be received by warehouse. So here the activity is to unload the goods from the transportation vehicles. So actually, most of the time it is done by it is done manually only. So, like unit load shipments, like reduce, we have seen reduce that unloading time also. Then in storage handling, it consists of movement within warehouse facility only. So and another one is shipping. Shipping consists of like checking and loading orders onto transportation vehicles. So those are the main objectives of material handling method system. So the content which is being there in the lecture notes are covering transport system, then material handling, logistics, material characteristics, then flow rate, routing and scheduling, and then plan layout, unit load principles, material transport equipments, vehicle management, conveyors. So we'll see the questions one by one, and we'll try to like explain all those things. So basically what we have understood from that material handling is defined as like movement, protection, storage and control of materials and products throughout the process of manufacturing and distribution, consumption and disposal. So this is the basic definition of material handling, and the are principles of material handling are: material should be moved as little as possible, and number two is reduction in time by using shortest routes, and number three is material movement in lots rather than individual. So rather than individual movement, it is like desirable, or it is the main recommend that material movement will be in lots or batches, we can say. And then the next one is gravity can also be used for like transportation. Then next one is rehandling and tracking of materials will be avoided generally. Then the next one is like repairing periodically, then maintenance, checkup of material, it should be there like regular maintenance, checkup of existing material handling equipments. So those are the material handling principles. And objective, we have seen that to reduce manufacturing cycle time, then provide better like working conditions, give smooth flow of materials, then it should like increase storage capacity, we can say, to provide higher productivity at lower manufacturing cost. Cost is the important factor in that material handling system, so it should be there. And then reduce unit material handling cost, and to use floor area efficiently and effectively. So to use the floor area efficiently and effectively, so that it can like maintain properly, and that regular maintenance should be done also in that material handling system. So those are the objectives, and must be that handling of materials must be performed safely, efficiently, obviously at low cost, in timely manner, accurately and without any damage of the materials. So the first question which is given as design of material handling system depends on the type of production facilities. Okay, so yes, it is like the statement is true or false. Obviously, the design of material handling system is dependent on the type of production facility only. This is because we can say different types of production facilities have different requirements for handling materials. If we say, for example, like can say manufacturing facility which produces heavy machinery, will require different material handling system than a facility that produces small electronics, so you can say. So factors as size, weight, shape, then of the material, fragility of the material handled need to be like in consideration to while we design the material handling system. So layout and flow facility also should be taken into consideration, to ensure that efficient movement of materials throughout the whole production process. So obviously the design of material handling system depends on the type of production facility. This is the correct option. This is the correct statement only. So the right option will be true. Then the next question is material characteristic doesn't affect the type of transport and storage equipment required. Okay. So like material characteristics is having we have seen that significant impact on type of transport and storage equipment. Like if we see an example, then like we can tell if material, say for example, material is hazardous, or we can say it requires controlled environment. So specialized equipment may be necessary to transport and store it safe, so that it can be in safe side. So that weight, size, shape, fragility, as we have talked, that of material or like affect the choice of equipment needed to transport and store it. So that is the reason like material characteristics should be carefully considered when selecting transport and storage equipment. So the statement which is given here, it should be false, right? Material characteristic doesn't affect, no. It should affect the type of transport and storage equipment required. So the correct option will be B, false. Okay. So we have seen the overview of material handling system and the objectives of material handling system. If we talk about the logistics, so two categories of logistics are there, like one is external logistic and one is internal logistic. So in external logistics, so transportation, like and related to that activities also, so it occur outside a facility, so between different locations we can say. So those like modes of transportation here will be rail, truck, air, ship, so, and like also pipeline. So those are external logistics. If we talk about internal logistics, then material handling and storage within a facility, so that will be an internal logistics. So like if we talk about that, so in material handling equipment, then transport equipment is there, so that we can move the materials inside factory, warehouse, or other facilities. Or if we talk about positioning equipment, so it will handle parts at one location. Unit load formation equipment, which will do the work as containers for holding materials, or like equipment for loading and packaging containers. And then another one is storage equipment, so where the materials are being stored, or it actually provides access to materials like when it is required. Then identification and control equipment, where like it kept the tracks of materials which are moving or which are being stored. So those are the material handling equipment categories available. Okay. So then even material characteristics also, as I have already talked about that in the previous questions. So like material characteristics as affects the type of transport, that is solid, liquid or gas, then size, shape, long, flat or bulky, we can say. In even in condition like hot condition, cold, wet or dirty condition it is there, then risk of damage. Say for example, it is whether it is fragile or it's brittle. As then safety risk like whether it is explosive, flammable, then if it's toxic or not, then corrosive. So in those terms it affects actually that characteristics get affected. Okay. So now come to the flow rate, routing and scheduling terms. So flow rate is nothing but it is the amount of material which is moved uh, per unit time. So if we say one example, then we can say pieces per hour, or we can say tons per hour. We have heard about those terms, right? Then pellet loads per hour. So actually when we talk about the material handling part, so material must be moved in individual units as batches or continuously. So we talk about that many pieces per hour, or that much tons per hour, or we can say pallet loads per hour. Okay. So just a minute. Okay. So the next one is routing. That is like pick up and we can say drop off locations. So it like move distances, then like routing variations. So and the next one is scheduling. That is like time of each delivery. So delivery when it is required, or use of like buffer stocks so that it can mitigate against late delivers. So that is called like flow rate, routing and scheduling. Now the one question is given here, amount of material moved per unit time is known as. So just now I have talked about that. So the right option will be flow rate, right? We have seen here that amount of material which is moved per unit time is called as flow rate. Okay. We use buffer stocks to mitigate against. Next question is given as a statement that we use buffer stocks to mitigate against late deliveries. So that is give like we have talked about that, right? In scheduling. So for that it is the true option only. So basically on to mitigate or like to avoid the late deliveries, what it is being done, like buffer stocks are being there in the industry or manufacturing lines or plant, so that it can avoid late deliveries. So the right option would be true. Okay, so next coming to that, so we have seen about flow rate, that scheduling and all those terms which are being used in material handling. So now like we'll say about that equipments which are being used in material handling. Okay, so if we talk about plant layout, so material handling equipment actually must be like we can say included in plant layout design. So plant layout types are there, like fixed position, process layout, product layout. So in fixed position, like plant layout like of material handling equipment as cranes, wastes, then industrial trucks are there. If we talk about process layout, then we can see hand trucks are there, forklift trucks are there, then automated guided vehicles, that is AGVs are there. If we talk about product layout, then we can say conveyors for product flow, then trucks for delivering parts to stations. So those are the plant layout types which are there available for material handling. Okay. So, if we talk about that unit load principle, so unit load should be as large as practical. So, for metal handling systems, actually it move and store. So, unit load basically what it does, it should be like in mass it is moved like handled at a time actually. So reason why we use unit loads in material handling, because like multiple items even like handled simultaneously we have seen in industries, so even required number of trips is actually reduced. Then loading and unloading times are reduced. So our main objectives are being followed here of material handling system are being followed in unit load principle. Then product damage is decreased. So those are the reasons we can say behind using unit load principle in material handling. Okay, so if we talk about the like one question is given here as which of the following material uh, handling equipment mainly belongs to the process plant layout. Okay, we have seen the equipments, right, and product layout and process layout, and like so among them conveyors, I can say it's a type of material handling equipment which belongs to product plant layout. So basically conveys what it does, like it used to move products and materials along the production line. So it is like they can be designed to transport products horizontally, then vertically, or in like incline. So conveyors like that's the reason it's in like we can say an integral part of production line. So even like if we see the other options, there are cranes, can then hand trucks, those are also used for material handling in manufacturing environments, but like those are not like included in process layout. So we have seen here in product layout the options are there. So those hand trucks are or hand trucks belongs to the process plant layout, and then yeah, and in product layout, conveyors is that which belongs to that product layout process. So that is the right option will be conveyors only. And the next question is also similar. Which of the following material handling equipment mainly belongs to the process plant layout? So we have seen in the equipments also. So here among the options, hand trucks belongs to the process plant layout. And trucks, forklift trucks, AGVs we have seen, which belongs to the plant layout. Okay, so the next question is also from the same portion only. Which of the following material, okay, fixed position layout. So from that we have seen hoist, right? So those are the examples of fixed position plant layout. So cranes are there, then industrial trucks are there, hoists are there. So the correct option will be B. Okay. So in general, unit load should be as large as practical for material handling system that will move and store it. So we have seen why unit load principle is being used in material handling. So we have seen the reasons behind using it. So from that, we can say like yes, unit load should be as large as practical for material handling system which move and store. So even like we can say larger unit loads which increase like efficiency of material handling systems also. So what it does, like it does it by it do that handling system which actually being reduced by number of trips required to move so a given amount of material we have seen. So even it is reduced that the amount of handling required for each individual item is also being reduced. So it finally like results in lower labor costs, then increased output, or like then reduced material damage. So that is the reason it should be as large as practical for material handling system which move and store. So the correct option is true. So which of the following can be the reason for using unit loads in material handling system? So we have mentioned the reasons as multiple items are handled simultaneously, then required number of trips are being reduced, then product damage is decreased. So like by grouping we can say individual items into unit load, multiple items are being handled in simultaneously, so it increases the efficiency of like we can say material handling operation, and like also at the same time we can say it reduce the amount of time labor required to move materials. Then required number of trips is also reduced. So we have seen that larger unit loads reduce the number of trips required to move a given quantity of material. So finally it results in the low transportation costs and reduce equipment usage and improve throughput. So and the next one is product damage is decreased. So when if we talk about that individual items in a into a single unit, so risk of product damage while transporting or handling will be reduced, or we can say unit loads can be also designed to protect products from damage during transport, or we can see use of larger unit loads which reduces the number of times that individual items needed to be handled, so it like reduce the risk of damage also. So those are all the reasons which are reasons behind using unit loads in material handling system. The right option will be option D, all of these. Okay. Okay. Now if we talk about industrial trucks, which is a fixed position material handling system we have seen in plant layout in material handling equipment. So that is industrial truck. That so basically there are two categories of industrial trucks, which is non-powered and powered. So one is non-powered, that is human workers push, or we can say pull the loads, and another one is powered. So in powered industrial truck, those are self-propelled or like guided or divide like we can say it's driven by human operator, or we if we say for example that is forklift truck. So those are the power industrial truck. So among them, and another one which is an example of we have seen here is that is process layout, plant layout. There, and the one example is automated guided vehicles. So, like it uses, we had seen maybe in previous one of the previous lectures also about AGVs. So basically what it does, it uses independently operated self-propelled vehicles guided along defined pathways are given for as a guide it is working. So types of AGVs which are there, pallet trucks which moves like in pallets loads along that predefined routes, and then unit load carriers are there, so which moves unit loads between stations, like in a facility which is there in. And so that is automated, that is the working principle of automated guided vehicles. And then their applications where that GVs are basically used in production and logistics. So we can say like driverless train operations are there. So we have heard about that, maybe like movement of that large quantities of material, so in a long distance. So it is being moved by driverless train operation. So, and another one is storage and distribution, also that movement of pallet loads between shipping or receiving docks and storage racks. So another one is assembly line application is there. So there movement of car bodies or major assemblies, sub assemblies like motors. So through assembly stations, those are moved. Then one we can say flexible manufacturing system, which we have seen one of the previous lectures also. So movement of work parts between machine tools. So those are there, like in HEV's application we can see in production and logistics. So okay, now one question is given here. Uh, Okay, one fill in the blank is there, is a material handling system that uses independently operated self-propelled vehicles guided along defined pathways. Okay, that is the definition of automated guided vehicle system, right? Because we have seen it's a material handling system which use independently operated self-propelled vehicles guided along a defined pathways. So used to move the materials and products by giving a defined pathway in which it is being followed from to move from one workstation to another, like or storage location in a facility. So without need for human intervention or guidance. So it can be programmed to follow specific paths, perform specific tasks. We can say, for example, as picking up, dropping off loads, can be equipped with some sensors and safety features to avoid collisions with other vehicles or obstacles in their path even. So that is how AGV works. So that is the like the so this is a given statement is a definition of automated guided vehicle system. So the correct option is option C, that is automated guided vehicle. Okay, the next question is Vehicle management helps to minimize interference between vehicles and prevent collisions. So basically, vehicle management actually is a key aspect we can say of material handling system design. So particularly if we talk about for systems that use automated guided vehicles or other self-propelled devices. So effective vehicle management helps like to minimize interference between vehicles and prevent collisions. So it basically improves safety and increase throughput. So vehicle management system use like combination of software and hardware to like control movement of vehicles and coordinate like activities, the multiple activities which are being there. So it includes use of sensors, cameras to monitor the location, then status of vehicles, and we can say communication system to transmit instructions, status update between vehicles, a central control system. So vehicle management systems include algorithms or artificial intelligence to like optimize vehicle routing and scheduling also. So it what it does, it adjusts vehicle behavior so that to change conditions or unexpected events as well. So yeah, the statement is given as vehicle management helps to minimize interference between vehicles and prevent collisions. Yeah, the statement is true. Okay. So like even like in vehicle management we can say one is traffic control, one is vehicle dispatching. Traffic control is given because to minimize interference between vehicles and prevent collisions. Then vehicle dispatching, onboard control panel, remote call station, center computer control. So in vehicle safety, like travel velocity of AGV, we can say it's slower than typical walking speed of human worker. So automatic stopping of vehicle if strays from guide path, if it deviates from the guide path, automatic stopping will be there of that vehicle. So then obstacles detecting system like in forward direction as I have talked about now. Then emergency bumper that brakes vehicle when contact is made with forward object, or warning lights, then blinking and rotating red lights are there, warning sounds or approaching vehicles. And in conveyor systems is there large family of material transport equipment which are generally designed to move over fixed paths. So in there like non-powered are there that materials moved by human workers or by gravity. And in powered we can say we have seen already is like in through fixed path using chains, belts, rollers, or even in mechanical using mechanical devices it's being moved. So the question here it is given as travel velocity of typical automated guided vehicle is slower than walking speed of a human worker. Yeah, it is true. We have talked about it, right? Then the next one is the forward motion of the car in the cartoon track. Okay, if we talk about cartoon track conveyor, so carts ride on a track and driven by a spinning tube. So forward motion of cart is controlled by a drive wheel, whose angle can be changed from 0 to 45 degree in forward direction only. 0 means that is ideal position. Okay, so forward motion of cart will be always controlled by a drive wheel. So, and the angle of that drive wheel can be changed from idle position to 45 degree, that is in forward position. Okay, and okay, yeah. So, question here is given as forward motion of the cart in cart on track conveyor is controlled by a drive wheel whose angle can be changed from 0 to 45 degree. Yes, the correct option is true. Then if we then okay, those are okay. Then if we talk about powered conveyor operations or features, so there are like basically two motions are there. One is continuous motion, another one is asynchronous motion. So in continuous motion, conveyor moves at like constant velocity. In asynchronous motion, conveyor moves with stop and go motion. So they stop at particular station and move between the stations. Okay, and like other like classifications of conveyors are there: single direction, continuous loop, recirculating. Okay, so powered conveyors like in asynchronous, so it like operates in a stop go motion we have talked about. So it allows independent movement of each carrier in a system. So if we talk about an example, then it includes power and free trolley, inflow tow line, then cart on track, and like some models that roller and like skate hole. So reason why we use like why we have included there, like it load accumulation or temporary storage we can maintain here, and it equalize production rates on different conveyors, and like smooth production cycle times along production line, accommodate different conveyor speeds along the pathway. So that is the reason behind including that asynchronous like powered conveyor. Then comes to cranes and hose. So if we talk about cranes, like handling devices for lifting, lowering, transporting materials as heavy loads, for those purposes, for lifting, for lowering, transporting materials, cranes and hoists are used. In cranes, horizontal movement of materials are occurring, and hoists, vertical lifting of material happens. Okay, so that is the difference between cranes and hoists. So cranes include hoists, so that crane and hoist like combination can provide both horizontal transport as well as vertical lifting and lowering also. Okay, so in hoist, like with technical advantages of there, that sketch we, if we draw a hoist, we can say like if we draw here. So this is, we can say, load. So the force will be in that direction. That is the flow. So this is a kind of force, and if we talk about cranes, those are, as yes we have seen, it is being used for like vertical lifting of material. So breech cranes are there, half gantry crane, then jeep crane are there. So if we talk about then cranes, so say for example, so basically in like crane host, so actually we have seen right in like crane and hoist combination. So crane includes hoist, so here it is included hoist, so for horizontal movement of material, and that is the crane rail, that is for vertical lifting. Okay, so this is the example of jeep crane. Okay, so one question is given as hoists are primarily used for horizontal movement of material. So is it true or false? Obviously it is false, right? From the example also, from the sketches also we can refer. It is used for, hoists are used for vertical lifting of material. Okay, it is being used for vertical lifting of material. That is the reason in crane and hoist combination, like crane use includes hoist for horizontal transport, and crane does the job of vertical lifting and lowering. So the correct option will be false. And cranes are majorly used for vertical lifting. No, cranes are used for horizontal movement of the material, and then like hoists are used for horizontal move. Sorry, hoists are used for vertical lifting of the materials. Okay. So horizontal lifting, horizontal transport is given, that support is given by crane rail, and hoist is for vertical. Okay, so the right option will be B for question number 15. So those are the few questions I tried to explain like so that we can get an overview on that material handling and the content which are being discussed in lecture notes. So apart from that, any doubts, anything else, any doubt?
No, madam. Thank you.
Okay, fine. So if there is no doubt, then you can leave.
Okay.
Thank you.
I may leave,
Yes,
ma'am.
yes.
Oh, thank you.